when we're done talking here, because there's a really good blog post recently about some things that Amazon's doing wrong with like ICMP, for example, and some of the default builds. And I'll point you to a blog that explains why what they're doing is wrong. So that was a, 20-minute diversion. But now back to the Google Go part. So Google Go is an open source, statically typed, compiled, garbage collected, concurrent systems programming language. Thank you very much. You can all leave now. This is the money slide, right? This is sort of the high-level picture. It's what you need to know. Of course, we're going to delve into a little bit more detail now. So this is, I love XCD, as you can tell. This is one of the problems that Go is sort of very much targeting, right? Large C++ projects can take a long time to compile. They wanted a statically typed language that has the feel of a dynamic language. So their way of approaching that was to have a compiler that compiles very quickly. And they actually have two compilers, one based on the Plan 9 compiler, and it's very fast, but has less optimized code, and there's also a GCC Go compiler that's slower, but has much faster executing code. So this was meant to replace C, C++, Java, not JavaScript, and not assembly. Or C in certain cases where you're doing some really funky stuff with memory. And we'll get into that a tiny bit later. So the thing about Go, and part of the reason that my first presentation was boring, is because it's written by Rob Pike, Ken Thompson, and some really other smart people, right? They know what the heck they're doing, and it's sort of like a simplified version of C, and in many ways it's very simple and very boring, right? Which is good. You don't want lots of rough edges and fancy things that don't work. So you can probably all guess, right, what